So the two of the representatives, one is from the boy side, other from the girl side. Kindly please unmute it, okay? Because we require some sort of interaction. Okay. So this is input of an AM modulator. In this problem, they have given you are feeding an input to AM modulator, 500 kilohertz carrier, frequency of the AM carrier, and its amplitude is 20 peak to peak. Message signal frequency is 10 kilohertz, and that is make a sufficient amplitude, that is variation in the output, plus or minus 7.5 V peak to peak. So you are asked the following. Number one, you have to determine the frequency of the lower side band, upper side band, okay, and you are also asked to find out the modulation coefficient, modulation index, and you have to also draw the voltage spectrum of AM double sideband full carrier, and you are also find out the V max and V minimum of the envelope, okay, and finally you have to write the expression of AM double sideband full carrier with this equation, okay, derived equation. So let us start our proceedings. That is our problem, okay, right? Now in your derivative part, you have a lot of first one is that you are asked to find out the frequency of the LSB and USB, okay, right? Now you go to equation number probably 11. Hello?
Yes, sir.
Yeah. What's your equation number 11 says?
VAM of T.
Yeah, VAM of T equal to AC cos 2 pi FCT
plus MAC by 2 into cos 2 pi FC plus FM of T plus MAC by 2 into cos of 2 pi FC minus FM of T.
Okay, right. So I can do one thing for better understanding. We can parallelly open this one. So yeah, I think it's big ambiguity. I can do one thing. Oh, correct. Open with MS Paint. So this is your formula. Let me quickly copy it. So I think this is your formula. Am I right? AC cos 2 pi FCT plus MAC by 2 cos 2 pi FC plus FM, FC minus FM. Okay. Am I right?
Yes, sir.
Okay. Now you have to find the solution for the first case. So what are the things given? FC, that is carrier frequency. So how much? What is the carrier frequency? It's 500 kilohertz. Then we have a message modulating frequency, FM. What is the value of FM? It is 10 kilohertz. Okay. Then we have a, I think for first case, I think this too is necessary. Okay, FC, FM. Then you have an amplitude of the carrier. So it's AC. Yeah. Excuse me.
Starting of the class, you have displayed some other problem, sir. You have written some other.
Which one?
I think power carrier. Say the modulation index and resistance were given, sir.
Oh, right. So correct. I can do one thing. So I think better. I again share it. So now it is displaying. Hello, Harish.
Again, same problem, sir.
Same problem.
So I think the second sum you have displayed first time. Sir.
No. Actually, my screen I'm displaying the first one. Okay, right. So better I can do one thing. Okay, right.
We shall write this question again.
Pardon?
Shall we write this question, sir?
No. Oh, correct. So let me do one thing. Okay. So we have not written the question itself. Okay.
Yes, sir. First time you have written the second question.
Correct. So now which part is displaying? First or second? The input of a modulator is 500 kilohertz.
So that part is visible.
The second problem is displaying or first problem is displaying?
So the input of AM modulator is 500 kilohertz.
Yeah. Right. Okay. So I can give 2 more minutes. Kindly please write the question. Shall I proceed with the solution? Hello?
Okay, sir, you can proceed.
Okay. So this is a problem they have given. So I'm just going to find out the first case. The first one is they are asked to determine the frequency of the lower sideband and the frequency of the upper sideband. From the equation 11, frequency of the lower sideband is what? So whether the equation 11 is displaying this in your screen? Hello?
Yes, sir. Yes, sir.
So frequency of lower sideband is what? Fc minus Fm. Upper sideband is Fc plus Fm. Okay. Because you know that in voltage spectra, you have 3 things. Left hand side Fc minus Fm. Center frequency is what? Fc. And right hand side, there is upper sideband is what? Fc plus Fm. Am I right? Shall we move on? Okay. So I had to find out the first one, the frequency of lower sideband. So second one, I had to determine frequency of the upper sideband. So the frequency of the lower sideband is given by the formula. It is Fc minus Fm. Okay. So what is Fc minus Fm? Fc is 500 kilo. Yeah, right. Let me finish. 500 kilohertz minus 10 kilohertz. What's the value? It's 490
kilohertz.
It's 490 kilohertz. Then for upper sideband, what might be the value? For upper sideband, the formula is same, but tilted for Fc plus Fm. So yeah, right. So it is 510. Am I right? Okay.
Yes, sir.
So the first solution for the frequency, you have determined the frequency of the lower sideband and upper sideband. So this is formula to calculate the frequency of the lower sideband and upper sideband. How I had derived this formula? From the equation number 11. Equation number 11, they have given Fc minus Fm of t, Fc plus Fm of t. Okay. So lower sideband is Fc minus Fm. So what is Fc? 500 kilohertz minus 10 kilohertz. So it is 490 kilohertz. Frequency of the upper sideband is given by the formula Fc plus Fm. So I'm substituting the value of Fc. Fc is 500 kilohertz. Fm is 10 kilohertz. So it is 510 kilohertz. So this is the frequency of upper sideband and lower sideband. What is the second? They have asked, you have to find out modulation index. The small one is modulation index. Capital one is what? Percentage of modulation. Oh, correct. So the first solution is, okay. The second one you are asked to find out the M and, okay. So let me do one thing. What is small m? Small is m equal to
AM by AC.
AM by AC. So I think it is given in the equation 4. Okay, correct. Equation 4 states that sorry, it is small m. I can do one thing. Small m is equal to AM by AC. So what is AM by AC? 20 divided by 7.5. What's the value? Yes.
2.6, sir.
I think representative roll number 23. Hello.
So
Can you please find out the modulation index value? What is the modulation index value? 20 divided by 7.5 is what?
AM by AC.
Yeah, AM by AC. What's its value?
AM value is 7.5, sir.
But
you have wrongly written.
Why is it right? 7.5 divided by 20. Okay. So
0.375.
0.375. 0.375.
1.5.
Okay. So what is capital M? Capital M equal to small m
37.
to 100%. Okay, let me write the formula. So it's equal to what?
37.5%.
So whether it is under modulation or over modulation? 37 point. Whether it is under modulation or over modulation? So it is less than 100%. So automatically this modulation is a what kind of modulation? Under modulation.
Over modulation.
No. Over modulation is above 100%.
Okay.
Okay. This is under modulation. So we are expecting 100% modulation, but actually modulation is happening what? Only 37.5%. Okay, right? So this is the solution for the second one. Second solution. Second question is that you are asked to find out modulation index and percentage of modulation. So modulation index formula M equal to AM by AC. You know the value of AM. AM equal to 7.5 volt. AC equal to 20 volt. So 7.5 divided by 20 is equal to 0.375. And modulation percentage is what? Modulation index into 100%. So it is 37.5. So here the modulation is under modulation. What is the third solution they are asking? Voltage spectra. Okay, right. You are asked to sketch the voltage spectra of your AM double sideband full carrier. So for sketching voltage spectra, okay, right, you require following. Let me delete this. Okay. So how a voltage spectra of your AM double sideband spectrum look like? Okay, let me quickly draw. So this one is your voltage spectra. You have a carrier. You have a lower sideband. You have upper sideband. Am I right? This is how your voltage spectra will look like. So what is the frequency value here? Lower sideband. Yeah, calculator. What is the lower sideband frequency? Yeah, right. Roll number 23. You have to answer this one. So what is the lower sideband frequency? Hello, madam. Hello, roll number 23. Hello.
So
Yeah. So what is the lower sideband frequency? Just now we solved lower sideband frequency, LSB frequency.
FC minus FM, sir.
Yeah, right. FC minus
490 kilohertz.
490 kilohertz. So 490 kilohertz. Because third, they have asked to sketch your voltage spectrum, 490 kilohertz. What is upper sideband frequency?
510, sir. Kilohertz.
510 kilohertz. Very good. Okay. What is the center frequency value? What is center frequency value? Center frequency is the frequency of the carrier. It is given in the problem itself. Okay. So it is what?
Yes, sir.
500?
500 kilohertz.
Okay. Yeah, something is missing. What are the components are missing? We have sketched the frequency. Okay, right. X-axis. What is in the Y-axis?
Voltage.
Voltage. So there's something is left out. Okay, right. Let me solve this one. So amplitude of carrier, you know. What is amplitude of carrier? AC is equal to 20 volt.
20 volt.
Right. Very good. Now you have to calculate what? Two side. Okay. Now go to the equation number. Excuse me. Go to the equation number. The same equation, probably, I think so. Equation number 11. Okay, right. In equation number 11, you have amplitude of the lower sideband and upper sideband is given. What is the amplitude of lower sideband and upper sideband?
MAC by 2.
Okay, let me finish it out. LSB is equal to USB because both lower sideband and upper sideband frequency is equal to small m into capital AC divided by 2. Am I right? This is the formula to find out. Okay, right. So now you have to find out which one. Lower sideband and upper sideband. So m is what? Here? What is the value of m?
0.375.
0.375 into
20.
AC in 20 volt. Okay, right? Whole divided by 2. So what will be the answer?
3.75.
Hey, you just wait. Okay, right? So I need some representation from ladies' side. Representative. Hello. Roll number 23. Hello. Hello. Harish. Whether she is in online or not?
She is online, sir. I think network issue.
A network problem. So, in ladies' side, who's the best interactor? So, very good interaction with the faculty members. So she can answer. Okay. Roll number, please, because I think it is a one-way communication. Because I am getting a response from you only. I'm not getting a response from that side. Okay. Shall I randomly pick any number, or you just point out somebody else?
Shall you randomly pick, sir?
Okay, randomly pick, sir. Okay, that's a very good answer. Huh? Okay, let me. So it's roll number 47. Hello.
Sir.
Yeah, right. Roll number 47. So
Yes,
I need your cooperation throughout this tutorial session because I am not getting a response from that side. That's from girl side. Okay, I think your representative is stuck with the network issue. Okay, so she can't able to convey her information. Okay, due to some problem. So you respond my question. Okay, so what will be the answer? Hello. So here LSB and USB.
3.7, please.
0.375 into 20.
3.7, please.
3.75. Okay, right. So the value is what? It is 3.75. What is its unit? 3.75. Hold. Thank you. So now the job is over. Let's add on. Am I right? So here this side is 3.75. It is 3.75. What is the upper one?
20 volt.
Can do one thing. So then it is better. Oh yeah. So this is you have to sketch voltage spectra. So the problem is over. What is the third one? Asked in your problem, you have to determine the voltage spectra AM, DSB, FT. So keep it in mind that in your first exam, that is class test or unit 1 exam, cycle test, the question might be in a mixed form. Mixed form means that you should have a problem, you should have a derivative part, and you should have a theory part. Kindly please don't put the question just like this one, describe, explain, because what we have decided in the course monitoring committee meeting, our course coordinator meeting, we just want to kindle the minds of you. So instead of directly asking questions like explain and what, we are just going to ask the questions in the form of that is problematic case studies and derivative part is there. So please concentrate on tutorial. Okay, so there's a possibility of this sort of question pattern will be there in your cycle test and in your university exams. Do you get the point? Whether it is understandable? Hello?
Yes.
Okay, right. So we have solved up to 3 cases. First one, second one, and the third one. Voltage spectra of AM, DSB, FC. Next, what they have asked? They have asked, you are going to find out the Vmax and Vmin of the envelope. Okay. And last one is an expression of AM, DSB. So we can first solve the expression of AM, DSB. What is the expression of AM double sideband full carrier? What is the expression? Equation number 11, am I right? What is your equation number 11 says that? VAM of T equal to, okay, what is the value of AC? AC is 20, substitute the value, okay, right? Cos 2 pi FCP, am I right?
Yes.
So 2 pi, so let me put 2 into 3.14, or I can do one thing better, I can insert equation symbol is there. So the pair it is there. 2 pi. What is FC? What is the value of FC?
500 kilohertz.
Right. 500
Kilohertz.
Yeah, right. So here you doesn't need to mention the notations. Okay, right. No need for what is that? Then MAC by 2. What is MAC by 2?
3.75
into
cos 2 pi
cos 2 pi
510
FC cos 2 pi is 500. What is its value minus?
510. Okay, so 5.
Yeah, you can just put 510 T minus 3.75 cos
2 pi.
2 pi 490. Okay, so this is the derived AM part, that is the AM of comes in the suffix. Okay, so now we have found out the first one, second one, and the last one. I think I can recolor it better because you love this color. So you have to find out V max and V minimum. What is the formula for V max and V minimum? Now go to your derivation. The formula is given in the derivation. That is derivation. You have to find out V max and V minimum. Oh,
16th equation.
Probably okay. Let me check it out. Yeah, right. V max and V minimum is given in equation number 16. 16 and equation number 18 is there. What is your V max value?
AC plus.
Yeah. Let me quickly. Okay. So I have to find out V max. V max equal to capital AC. Okay, plus what is MAC by 2? Where is that MAC by 2? So for V max and V minimum is given in equation 16 and so this is the equation for V max and V minimum. Okay. So substitute the value. What is AC? AC equal to
20 volts.
Yeah, 20 plus 3 point.
MAC by 2.
Sorry, MAC by 2 is what?
3.75.
Yeah, 3.7. 3.75 plus 3.7. Yeah, what will be the answer?
27.5 volt.
So the answer is 27.5 volts. Okay, so V max is 27.5 volts. So we are rewriting the equation for V minimum also. So what is the equation for V minimum? So this term will become minus, and this term will become minus, and this term will become minus, and this term will become minus. So what might be the value?
12.5 volts.
20 minus 1.5. It is
12.5 volt.
12.5 volt. Very good. So now we had found out all the values. As I can do one thing. So this is your problem. So we have just solved all the questions. So correct. So let me quickly repeat our problem. So in problem number 1, they have asked to find out frequency of the lower side band and upper side band, modulation index, percentage of modulation, and V max and V min of the AM envelope, expression of AM double side band full carrier, and they are asked to draw the voltage spectrum of AM double side band full carrier. Okay, and what is given in the problem is that they have given carrier frequency and its amplitude, message frequency and its amplitude. Okay, right? And you are asked to find out the following things. So first is that how the frequency of the LSB and USB can be found out. So from the derivation, we are just going to the equation number 11. From the equation number 11, we know that LSB and USB value is what? LSB is FC minus FM. So what is FC? 500 kilohertz. So the carrier frequency. FM is the message frequency, that is 10 kilohertz. So 500 minus 10 kilohertz is 490 kilohertz. And upper side band is formalized FC plus FM. So what is FC? 500 kilohertz. FM is 10 kilohertz. 500 plus 10 is 510 kilohertz. So we have found out the first one, frequency of lower side band and upper side. Then we have to find out what? Percentage of modulation and modulation index. So modulation index formula equal to AM by AC. That is amplitude of the message by amplitude of the carrier. Amplitude of the message is what? 7.5 volt. Amplitude of the carrier is called 20 volt. So this is the value. It is 0.375. Percentage of modulation is 37.5%. So it is under modulation. Okay, the modulated signal is under modulated signal. So now we are going to draw the, based upon the derived value of the first one, we are going to draw the voltage spectrum of AM double sideband. So this is a voltage spectrum of, so x-axis is frequency component, y-axis is amplitude component. So axis in lower sideband is what? FC minus FM. FC minus FM is what? 490 kilohertz. Upper sideband is FC plus FM. It is 510 kilohertz. What is F? F is given in the problem itself. So its FC is what? 500 kilohertz. So based upon this, we have just drawn the x-axis. Y-axis is derived as what? Lower sideband is derived as what? MAC by 2. So from equation number, same equation number 11, we know that LSB and USB amplitude is what? MAC divided by 2. M is a modulation index, AC is the amplitude of the carrier divided by 2. So when you substitute the value, that is 0.35. We know that M equal to 0.35. Amplitude of the carrier is 20 volt. Divided by 2, we will getting 3.75. So I'm substituting 3.75 in the lower sideband and upper sideband amplitude. And amplitude of the carrier is given the problem itself. So 20 volts. So based upon this detail, I had sketched the amplitude modulated spectrum. Okay, that is double sideband full carrier. Then what is asked? They are asked you have to find out the V max and V minimum of the envelope. So it is given by the same formula. That is formula number 16 and formula number 18. That is equation number 18 and equation number 16. Use the formula number V max and V minimum. Sorry, this one is, I had to modify V minimum. Yeah. So this is the formula. AC plus MAC. That is amplitude of the carrier plus amplitude of the upper sideband plus amplitude of the lower sideband. So when you sum all these things, you will get 27.5. And V minimum is amplitude of the carrier minus amplitude of the upper and lower sideband. And you are getting the value, after approximating, you are getting the value 12.5 volt. So you have calculated the fourth one. What is the last one they have asked? You are going to write the expression of AM double sideband full carrier with respect to the derived value. So you have derived a lot. So from equation 11, what is our equation 11? Equation 11 is the your derived part of amplitude modulation with double sideband suppressed, full carrier. So it is AC cos 2 pi FCT plus this one is what? MACT by 2 cos 2 pi FC plus FM of t minus cos MAC by 2 cos 2 pi FC minus FM of t. So I'm substituting the value. You know the value of AC. AC is for 20 into cos. So FC is what? 2 pi 500 of t. Okay, do you get the point? So anybody having a doubt? Hello? Is it okay? Is it understandable?
Yes, sir.
So I'll give 5 more minutes. Okay, right? Okay, or I'll give 2 more minutes. You do one thing. You go through the problem, solve the problem. So I can give a time. Now, kindly please take a note of it. There's a group people, slow learners are there. So kindly take the note of this value. So make it fast. We have only 3 more minutes are there. Okay, right. I am giving you one problem homework for you. Okay. You have to do it in the home and submit it in the classroom. Tomorrow we are having a tutorial test. Yes? Is it okay? Hello?
Okay, sir.
Tomorrow which hour? First hour, second hour, third hour? Which one? I think probably 11 o'clock. Am I right?
Let me see.
Tomorrow, yeah. Kindly check it. Tomorrow 11 o'clock, I think so.
It's 12 o'clock.
12 o'clock, okay. Tomorrow 12 to 12:45 you have a tutorial test. You have to solve the tutorial and submit in the classroom. Manually solved. I think a multiple choice question, I actually discourage multiple choice question because what the people will do in the sense that they randomly select A, B, C. That's it. They won't work it out. Okay. So what I am just going to follow is that instead of having a multiple choice question, you send me the derived or the solved papers. Okay, right? just have a snapshot of the solved answer script and upload it in the Google Classroom. I will just verify it. Okay. Tomorrow I'm just going to ask 4 problems. Each problem carries 5 marks, total 20 marks. So tutorial 1 is over. So I think marks of the tutorial will be taken care or taken in count for your final internal marks. Okay. So in our ADC, your internal mark is purely based on your performance. Okay. If you perform well, you will get a better mark. Correct?
So in the expression you are written minus, sir.
Which one?
Expression of AM.
This one is plus, am I right?
Yes, sir, that's plus.
Now you take down the second one. Okay, I'm just scrolling down. This is a final. P max and D minimum. Yeah, right. So this is a homework problem. Oh, correct. Take a note of it. Harish, whether the problem is displaying in your screen? Hello?
Yes, sir. Sir, it's visible, sir.
Okay, it is. For solving this problem, okay, right, you have to refer the following equation in your let me quickly go through the thing. That is equation number 24, equation number 25, equation number 27. Okay, and you have to draw the power spectra. Power spectra, what is its x-axis? X-axis is frequency, y-axis is power. Okay, so the same problem. So what is the frequency of lower side band? 490 kilohertz. What is the frequency of the upper side band? 510 kilohertz. What is the center frequency? It's okay. For the first problem, you are just going to calculate the power also. So this one is your homework. Okay. So in this problem, they have given amplitude of your AM is 20 V peak to peak. Modulation index is 1. Okay. Then carrier amplitude. Then you have a resistance is 10 ohm. You substitute these values in the formula. Probably 27, 26, 25. I think so. Yeah. Confused. Substitute in Equation 27, 26, 25, and 24. We are going to substitute the 4 formulas. So that's it. Our class is over. Tomorrow, before entering into the tutorial session, you are going to submit this homework. Okay, right? After that, you are just going to attend the tutorial problems. So totally 4 problems are given for a tutorial exam today, sorry, tomorrow, and each problem will carry a weightage of 5 marks. Okay, right? And instead of MCQ question, you have to take a note of the problem. Okay, right? And write the questions followed up by solved answers. So I never encourage an MCQ question, because the reason is that some of you don't work it out and you just simply mark A, B, C, D. Within matter of few seconds, you will finish the entire tutorial. So what I am going to do in this tutorial session is that instead of MCQ question, you have to write it. Okay. Take a snap of all your tutorial problems, submit it. Okay, right. So shall we wind up? I mean, yes?
Yes, sir.
Okay. I think most of you are noted this questions, correct? So tomorrow you are going to submit this question. This is a homework problem. Okay.
Okay.
For this problem, we will refer the equation 24 to 27, 24, 25, 26, 7. Okay. Yeah, who is roll number 21?